So welcome to a LiveWise event, and these are the very first of a series called What's the Future series. So we're going to run a whole series of events, probably over the next 2 years, one every semester. This one's obviously What's the Future of 3D Printing, and then the next one is What's the Future of Sensors, is that right?
Sensor technology.
Sensor technology, okay. So keep an eye out on our website and our newsletters, and we'll have more information about that. It's so lovely to see so many of you. And this one, as I said, was What's the Future of 3D Printing? Now, we're going to start with a correction, because we shouldn't really call it 3D printing. We should be calling it additive manufacturing. But Joe Blogs in the Street and your media has decided to call it 3D printing, so we're kind of stuck with that. But really, technically, it's called additive manufacturing. Why is it called additive manufacturing? Because we build up solid 3D parts from a digital format, and we build them up layer by layer. And additive manufacturing is an umbrella term, if you like, for a range of manufacturing techniques, but they all have the same thing. They start with a CAD model, computer design, and then we build material up layer by layer. So an analogy of that would be subtractive manufacturing, or what we would know as conventional manufacturing, is we take a block of material, we mill things away, drill parts of it away to get these 3D objects. That's the complete opposite for additive manufacturing or 3D printing. So hopefully that's not confused you too much, but I thought I'd give you a bit of an introduction to what it is. So it's an umbrella term for around 10, maybe growing more, maybe 12 techniques that we would class as additive manufacturing. So a layer by layer process. And how we're going to run tonight is we're going to do about 40 minutes, 45 minutes of an informed discussion of the panel. And we'll ask you to refrain from asking any questions until at the end. And then we're going to open it up to the floor. And any questions you have on 3D printing, additive manufacturing, we're going to try and answer for you, as long as they're fairly sensible ones. Okay, so I'll introduce myself. I'm Kate Black. I'm a lecturer here in the School of Engineering. I'm actually a chemist by training. And I work in additive manufacturing. I develop new materials that can go in these 3D printers, these additive manufacturing techniques, so that we can broaden the palette of materials that can be processed by these techniques. And I'm going to pass you over to Candice. We'll go that way.
Is this loud enough?
Just hold it slightly.
Slightly now, yeah. Brilliant. So I'm Candice Majewski. I'm a senior lecturer in mechanical engineering at the University of Sheffield. I also work on materials for these processes, which is nice. And also I do quite a lot of teaching in this area, so talking to our undergraduates and MSc students and sometimes outreach activities.
Hi, I'm Rebecca Davenant. I think that's good. There we go. I'm a lecturer in the philosophy department here, working on philosophy of technology. We have a module called Philosophy of the Future that I coordinate. And I suppose most of my research is in AI, but I was invited along to provide an outside perspective.
Yeah, more of a philosophical, ethical point of view.
Hi, my name's Rachel Park and I'm a freelance journalist. I've been covering these technologies since about 1996 and it's where I specialise in. Whereas many of these ladies have a very deep knowledge of these technologies, I don't. Mine's quite a broad knowledge.
Hi, I'm Sophie Jones. I'm the General Manager of Added Scientific. We're a spin out of the University of Nottingham, which has one of the world's largest research groups in 3D printing. So the things that we do are the weird and wonderful stuff like printing pharmaceuticals or printing electrical components. So I've got quite an interesting team.
Okay, so I'm going to start with the first question. And I started with this question because when I go to parties or I'm in a pub, everybody asks me this question. So I'm going to ask you it, first of all. Do you think in the future everybody will have a 3D printer in their home? Just a show of hands if you think yes. Hands up if you think no. Okay, good, good. I think we're probably all in agreement on this panel that that's simply just not going to be the case. I mean, why would it? A lot of what the public are seeing at the moment are these very basic, simple 3D printers that are printing plastics. But why would you want that in your house, really? But the main crux of additive manufacturing or 3D printing is much more complicated technologies that you simply couldn't have in your home. They're very expensive to start with, and you need a lot of knowledge to be able to run those. Candice, do you want to say something about it?
Yeah, so I've given quite a lot of thought to this because I definitely will have a 3D printer in my home. Hopefully really soon. I've got to the point where my university students have 3D printers and I don't, although I have big toys to play with in our lab, so that's fine. So I think there is room for it in terms of hobbyists and people who are just excited by technology. What I also think is there's a lot of hype about, oh, you know, you can make replacements when you break something and all of this, and A, the printers and materials are not there for it, but B, I think we're at heart quite lazy, dare I say. So, you know, if I break something and I can jump on the internet and order a replacement for next day, why would I bother making it? Again, I probably would because I'd like the fact that I've made the 3D printed replacement, but I don't think in general that sort of activity is going to be that prominent.
So, when was it? It would have been about 2008. A man called Brie Pettis set up a company called MakerBot, and they grew and they did very well, and he put out a lot of press releases and he was very good at the media thing, and he had the whole world believing that everybody would have a 3D printer in their home. And then he sold his company for 660 million, and he went away, and we don't really see him anymore, and nobody has a printer in their home. I'm not saying this was a ploy to the press, but he sold the story very well. And I think the media went for it. I don't think everyone will have a printer at their home because of the materials issues and the complexity that we've discussed. If you look at what you've got on around you now, very few things are made from a single material or from a single process. Why would that change just because you can 3D print it?
I would just add to what Candice was saying about the hobbyist market and the maker movement. That is very much a growing segment of this industry, and I do think you will see more people having them in their homes, but the general person who, as Kate said, just wants to make something or a replacement part, that's not going to happen. Although you can never say never in this industry.
Yeah. That's true. I think there's also a safety aspect as well. How do you police safety? I mean, we see some of our very intelligent, well, supposedly intelligent students doing some quite crazy things, so you can imagine what the average person in the street might get up to. But we'll come on to that, I think, later in one of the other questions. So hopefully we've demythed that myth that there's going to be a 3D printer in every home in the future. I think that's simply just not true. But what other myths are there about 3D printing? A lot of people say that 3D printing is cheap. That's not always the case. Oh, it's cheap, let's use 3D printing. 3D printing comes into its own when it's bespoke, one-off parts very often at the moment. There's simply the speed, the amount of materials that are out there just don't make it applicable for mass manufacture of parts. So when a lot of people say it's cheap to print it, not always the case, unless you want to print out cheap plastic trinkets, which a lot of people do. Got anything to add? Any other myth?
Yeah, so I was thinking with that actually, I think part of what Kate said when she introduced it about it being an umbrella set of technologies comes into it, because yes, if I buy a £100 cheap desktop printer with cheap materials, then I can make stuff dead cheap, but what I can't make is a part to go on a car engine or a gas turbine or whatever. So I think a bit of it is that everyone kind of sees 3D printing as the process that they've seen, rather than, oh, there's cheap ones, there's more expensive ones, there's complex ones, there's different materials, there's ones that are good for this and not good for that.
I think also if you take, say, like the automotive industry, a lot of people think that they already use additive manufacturing, broadly across their sectors. They don't really. They use it with their Formula 1 cars, again, because it's a bespoke piece, there's a lot of money to go in there. The military use it often because it's bespoke, they've got the money to spend it. But the automotive industry just don't use it because the speeds are not fast enough and the material properties aren't good enough. And the aerospace industry, exactly the same. Aerospace is even more that really it needs to go through a lot of, sanctions, regulations. So you do find it inside the plane, but the actual parts, the physical parts, it's not really a great uptake on that because of the speed, but also the material properties that we could get. But we're starting to see them encroach in these two sectors, automotive and aerospace. But that's simply because the materials are getting broader that we can process by these technologies. Sophie, do you have anything to add?
I think one of the things we have to think about when we're talking about cost is the relationship between the size of the part and the cost, because that's often really direct in 3D printing, a lot more so than maybe conventional technologies. So if you take, for example, the in-the-ear hearing aid, there's over 12.5 million in-the-ear hearing aids printed every year. That's an astronomical number, really, and the reason they're doing it is purely because of cost. It's a lot cheaper to print a hearing aid shell than it is to mill it, which is how they would have conventionally done it. Likewise, if you've ever had the Invisalign invisible dental aligners, I think it's 80 million of those are printed every year. Again, that's a cost thing, and because they can go direct from your digital scan data. So for some of those applications, yeah, it's absolutely about cost, but in those cases, they're really small products. Not turbine blades or HVAC ducting for aircraft or whatever. When we're looking at those big components, or say the F1 components or whatever, then we have to start looking at other reasons apart from cost as to why you'd use additive manufacturing. So things like lightweighting or improved complexity, improved fuel efficiency, that kind of thing.
I would just actually add to that when you're considering additive manufacturing for applications, it is about matching up the application with the process. And as Kate referred to before, there are 10 or 12 different processes. So we've talked about the smaller plastic machines that you can get for maybe a couple of £1,000, but you can also find working in industry on serial production lines £1.5 million metal additive machines that are producing parts quite a lot bigger than the hearing aids, about this big. I actually just saw one this week at Siemens Power and Energy facility in Sweden, and it's probably about 2 foot high, and they are producing metal components, serially produced, and I think they said it was about 8,000 a year they're producing. And they've got 4 EOS machines, so 400 fours, and it's a really impressive facility. Now, Siemens is a huge global company, lots and lots of money to invest in this technology, validate the processes, and that will trickle down over time, but it's not going to happen overnight.
We did have a metal printing machine, as Rachel was saying, in Liverpool. Actually, it was the largest SLM machine in the world. And you could stand in it, and it never ran. It never ran because we couldn't afford it to run it, because the gases that you need to make the atmosphere inert in there cost an arm and a leg. But it was a kind of a concept machine, really. It's now been dismantled and put in the basement of the university, but it was there for many years. And that, yeah, it was a Renishaw machine. Yeah.
That's incredibly sad.
Mm.
If anyone wants a machine to...
I'm going to nick some parts of it to do something else to it. And that kind of brings me on to another question I had here is, do you think, this is to the panel really, do you think AM will be able to produce complete large structures like aircraft wings? And if so, what do we need to make it happen? Or will that never happen?
To the first part of the question, I would say no, that's not going to happen. AM fits where it fits, and it's good, it's really good at some things, but as part of a whole manufacturing process, which will also include your subtractive manufacturing, rejection moulding, you have to put it all together to get the best fit and the most value, and AM definitely does have value, but not for everything.
Do you have anything to add to that?
That was another method.
Okay, another method. I'll come to you. I was just going to say about civil structures, so buildings. There's a lot of large buildings. I'm sure some of you have seen them. China lead the way in this. They extrude concrete and composite material to build housing. This can often be used for humanitarian aid when we need to print or make shelters at speed. So in that sense, I think you can build large structures if they're not multi-component, really, and it's the materials that key. So if there's one material there, it's concrete, doesn't really need much else. Somebody else can put in the windows after the doors and the fixtures and fittings. So it really is, I think, is the materials that are key. But you wanted to add another myth that you had. Okay.
Yeah, so my personal favourite myth is the one that we can make things using 3D printing that you can't make using any other method. And so I have a wonderful example of this. I sat in a conference and there were probably 200 of us in the audience. And the presenter handed around this most ornate, intricate structure. It was like a fruit bowl, but really complicated, beautiful geometries. And he handed it around the room and he said, so, we'd all agree that you couldn't make this any other way. And we all went, yeah, we're brilliant. So, additive manufacturing is amazing. And then he handed around a wooden version of the same thing that had been handcrafted by some guy who was an expert woodcarver. And he made every single person in the room take it and touch it and feel a bit stupid, and then carried on. And so the point he was making was, I've yet to see something you couldn't make using another technique, but it's about the efficiency. So paying that guy to work for 2 months on this fruit bowl is not economical and it's not efficient, but you can still do it. So
the skill set as well. So additive manufacturing takes away that skill set. You don't need the same craftsmanship as you would previously to make those parts, I think. It's really what we're saying. And again, it's down to cost. Why would you use a human if you can print out some of those complex shapes and structures?
I'd just like to add something on the cost. So yes, it does cost a lot for the big industrial machines and the price per part. But what a lot of these companies are considering is not the cost per part, but the value over the lifetime of the product. And that's where AM can have a huge impact and can actually make a lot of sense.
Okay, before we go into more of the interesting ethical and philosophical aspects, which she's just sat at the end going, will I ever get a chance to speak? I'm going to finish off with, what do you think, can we summarise what the key limitations of additive manufacturing are at the moment that are going to be here for a while before we move into the next generation? What do you think the key limitations are?
I'm going to go off-ball here, I guess. So I think there are technical limitations. I think one of the biggest limitations we're up against at the moment, I'm not looking at you, Rachel, because you're brilliant, but is some of the more uninformed media hype. So we see so many articles that, to be polite, are frankly nonsense, and are full of inaccuracies and are full of, we can make everything and we're going to make an entire aeroplane on a 3D printer next year and it will be brilliant and, everyone come fly on it. So that's what I think actually is one of the biggest limitations, is getting people to understand what's true and what's not true, and which bits of what you've read you can trust and which bits of what you've read are completely untrue and which bits are a sales pitch and all of that. So as well as the technical side, I think that's going to be quite an issue, I guess, for all of us to be helping overcome.
I'll be controversial. I think one of the biggest challenges we face at the moment is that we're generally led by mechanical engineers. And this is a problem because the machines that we're using at the moment, they look not that dissimilar to what they started out in the 1980s. And they started out in the 1980s because a group of mechanical engineers thought, hey, this could be really fun, and they made a machine. And it kind of worked, and they had in some cases, they literally had material lying around in their garage, and we still use that today. And we're talking about production machines that are based on architectures designed in the 1980s for prototyping. And I think until we starting with the materials and saying, this is the exact material I want to use, and I'm going to make a process that can use that exact material and get the exact properties I want, we're stuck. We're going to keep prototyping and putting prototypes into production applications. So I love you mechanical engineers, but we need some more material scientists.
And I'm going to go blah, 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 because it is materials, it is skills for AM. We need to develop a skill set in the UK and right across the world, actually, And also, I'm going to pinch one of Sophie's, which she mentioned back at a conference in July, and that is funding. We need to improve the funding that is available for small and medium-sized companies to get involved with AM and to really drive the applications.
I'd agree, and I'd agree actually, yeah, there are too many mechanical engineers in the room. Sorry, Candy. But yeah, no, I came to additive manufacturing with a completely different angle to my other colleagues in the department, because I'm a chemist and I came at it from a materials point of view. And I say this to my engineering students every year: if you don't look after the materials, engineering is just an idea, and it will remain an idea unless you have the materials to make them out of. Because everything in this world, what we're wearing, what we're sat on, this room, is made out of materials. And if we don't understand the materials and how they can be processed by AM, we're not going to go anywhere. So I would say that key limitation to me is the materials for additive manufacturing. Okay, so I'm going to start with a slightly different slant now. Rebecca, you're looking worried. Don't be worried. Could AM hold the key to solving world hunger? They do say, I can't answer that. A UN report a while ago said that the population, current population, is 7.3 billion people. And they're expecting to see that expand to about 9.7 in 2050. And there simply isn't the food to feed everybody. 1 in 9 people in the world go hungry, and 1 in 4 in Asia and Africa. And somebody from World Wildlife Fund predicted that we need to double the food intake that we have by 2050 if we're going to solve these. And in 2013, NASA, you wouldn't think food, NASA, but they did. NASA said, we want to try and get people in with new ideas about how we can feed our astronauts up in the space station